When we travel abroad or to new places, we often feel anxious and stressed about the novelty of our new environment. We often ask ourselves, can I eat the food here? Will I survive the climate? Is it dangerous? But did you know that the change in our environments, diets, level of anxiety can change our gut microbiome, which is the community of trillions of bacteria living in our intestines that are so essential for our health? The same is true for other animals, including those that are removed from their habitat for exotic pet trade. Wildlife trafficking is one factor causing the disruption of gut microbiomes. Not only are trafficked animals stressed about being removed from their natural surrounding, but they also may be fed inappropriate diets. Their disrupted gut microbiomes may end up causing digestive problems, suppress the immune system, and further exacerbate stress. Of course, conservationists have mobilized to try to save the animals from the pet trade. And for animals that are rescued, they often get to enjoy their natural diets again during rehabilitation. And if they're really lucky, they might be translocated, which is the act of releasing them back into the wild. But what about their gut microbiome? Does it return to its natural state or not? Because translocation itself can be very stressful for the animals who need to adjust to the wild. And even more, does the gut microbiome affect whether a released animal can survive on its own again? Well, these are my research questions. I hope to uncover the dynamics and reversibility of the gut microbiome of ex-trafficked wild animals in a rehabilitation and translocation context. I studied the critically endangered Javan lorises, one of the most trafficked primates in the world. I collect their feces at different stages of rehabilitation, from the time they arrive at the rescue center, throughout their rehabilitation, to their release into the wild and beyond. The bacterial DNA I get from their feces is sequenced to obtain information about the gut microbiome, like how many bacterial species, how abundant each species is in the community, and how it changes during and after rehabilitation and translocation. In general, loris translocations are often unsuccessful, and digestive issues are among the main reasons for this. However, no studies have examined the gut microbiome of ex-trafficked loris across the rehabilitation and translocation process. Understanding the loris microbiome is one step that should help us improve their survival rates after release. At least 80% of the Javan loris population has been lost over the last 24 years. I hope my study can enlighten us about the loris gut health and provide a new conservation tool to help turn that table and bring loris back from the brink of extinction. Thank you.